G'day folks. Well, I finally decided to can this old Phillips plasma. It's too old, standard definition, and it's been repaired a few times and it's blown up again. I know there's a fix for the clicking Phillips power supply, but yeah, I've got high definition plasmas and LCDs everywhere now, so there isn't really any point in fixing this or the JVC that I've got in my living room. I think I traded Brad some equipment for that one a while ago, and nobody really wants these old standard definition ones. I know I'm going to get a million comments saying people want them, but trust me, you don't want them. Especially when the panel's got as many hours as this one has. It's got a nice yellow tinge to it, almost like it's burning out. It just doesn't have that crisp look like a lot of the new ones do. Even my Hitachi, my mum's old one, she bought it about the same time this was made. I think it's only been repaired once, and that was a known factory fault, and they replaced the whole panel assembly a year after she got it, free of charge. So yeah, this one's made in 2004, probably second month. It's 2012 now, so it's done more than enough work. That, and it's very, very, very heavy. It's bulky and it's very heavy. So it needs to die. All these boards, the X and Y sustain boards, will be fine. I know what the problem is in the power supply. You just don't have the capacitors, resistors or MOSFETs to fix it. Because I did find shorted MOSFETs in the power supply as well, and I know they're only a few dollars each. It's just not worth it. Sick of looking at it. It's like a lot of projects around here. It's been kicking around. I haven't had the time to order parts. I haven't had the time to actually... Well, I have had the time to pull the power supply down and just check it, but that's as far as it's gotten, and that's as far as it's going. So let's pull this apart. We've got, I think this is Y sustain, I think that's X sustain. I can't quite tell. At least all the pinouts on these things are marked, apart from this ribbon cable. Not that I'm really concerned about keeping cables. I'm just going to keep the main boards. So it was repaired in 2005 by PDN, or Southside Electronics. Power input filter by Delta Electronics. Delta makes some pretty good stuff. We use Delta PLCs, VFDs and other shit at work, and they're pretty solid. But yeah, that's a sealed digital unit. Probably still good. I imagine it'd still be good. It's only a power supply issue with this thing. But yeah, that's various inputs, code. Yeah, Y sustain board or something. Whatever. I'll pull probably these little strip boards off them, buffer boards or whatever they are. I'll take them off it. Take the main panel drive board. That'll be alright. It's only stuff just to scavenge semiconductors and second-hand caps and things off, and even then they're old Samwa caps, so they're probably crap anyway. Yeah, PDP module is a S42SD, standard definition of course, YD06, manufactured 2004, 4th month, 15th day. Oh well. It can die to the mott, then it can go in the scrap bin. That's all there is to it. I don't need it. Well, I can't say I've seen a speaker like that before. With a dual magnets, dual voice coils and a single piece cone. That's odd. Somebody did ask me about these speakers and they wanted to know more info on them, and to be honest I thought it was like a moulded enclosure with two speaker positions in it, like two separate cones. I did not expect them to be joined like this. So I'm going to salvage them. I'm sure somebody will want them, but international customers beware. This thing weighs about a pound, so two of them plus packaging and everything could get a bit expensive, and that's generally why I refrain from shipping stuff overseas unless it's really small, light, or I really know the person buying it, like it's a big dollar item. But the main digital board, it's just got a few standard chipsets on it. Samsung, the Phillips ROM chip or something, like almost looks like a BIOS chip. Same with that, it's got specific numbers stamped on it. Programmable ROM, EEPROM, whatever. Yeah, I loosened these two main screws off and the whole panel has sort of come loose inside the housing, but I've got to get this frame and everything off too. So I'm guessing you take these off and it drops the panel into the front housing, and then you take this back plastic facade off and then you can lift the panel out by these. So the panel's going to come out as one separate unit, or I'll leave it attached to that, and no, even then I want to get these boards off. It's designed to be installed as one unit. You can't pull these boards off without stripping everything down, which is a bit of a pain. That's why I like newer ones. It's much easier to get to all the parts, and well, they aren't really any more repairable. They're just much lighter, much easier to get to. So I'll pull these top speakers off and then pull the rest of this plastic facade off, and then we'll work on stripping the panel assembly while it's sitting in the front fascia. It shouldn't go anywhere, I hope. Okay, we've got two layers now. We've got front bezel with laminated anti-static coated glass, which probably also doubles as a diffuser. It's got that thin copper strip around the outside. There's a darker layer on top of that, and it also appears like the copper's going through to the glass, but it's all grounded, so that's anti-static or something like that. But it's laminated on both sides with fairly tough material. I've tried breaking these before and they are tough. That's why I was using one with the Hyundai hot tube engine. If the thing did rev up and little bits fragmented out the side of the block, they'd just bounce off that and probably crack it, but a lot safer than standing in the direct line of fire with nothing between it and you. Not that I'd put myself in direct line with a flying con rod, just on a diagonal angle. It's better for shit to ricochet off something like this. And that's the panel itself. That's two layers. The outer layer has electrical traces and things on it, so does the back layer. And these plasma display panels are just rows and rows of little cold fluorescent lamps, red, green and blue. And these little connectors here, well, I shouldn't say little, they are millions of little wires through these connectors, light up each individual pixel in red, green or blue depending on what it wants to do. In a CRT, like a normal tube television, that's determined by the scan frequency of the yoke and the firing of the guns. The guns just stream electrons at the front of the screen, and the yoke determines what goes where through electromagnetic fields. Whereas this one here, again, it uses phosphorus, it uses inert gas. Whether or not it's under pressure, I don't know. I imagine it'd be under vacuum, since flat glass is not very good under pressure. But yeah, they're quite interesting when you work at how they operate. You can't see that though. It's just a bit of manufacturer's markings, top and bottom. No cracks in it, of course. The panel module itself's fine, but it's probably got a lot of hours on it, so being a standard def panel, it might as well die. Goo around the outside, Sikaflex or whatever that is. It's a shame, but I don't know, this old analog or old standard def with analog tuner, not worth screwing around with anymore. And they are everywhere, at least in Victoria, Australia anyway. You can find them on the side of the road in pretty much any hard rubbish collection now, and there's lots of them. Nice big plate of glass though. Okay, now to remove the panel. I'm sure that's not what they recommend putting it on at the factory, but well, it's soft enough, it won't break it till I'm ready to break it. This stuff's fun. There's probably a whole load of that under these boards too. This is a rather silicaceous goo. It's a thermally conductive mat. It's in various layers too. I had a fair bit of it, just ended up getting dust and crap stuck to it. I didn't protect it properly. But yeah, if you want to heat sink something or heat sink the back of a board to something with non-conductive material, this is the best shit. I don't know what it's actually called. I'd like to know. But yeah, you can see where all the pins and things were, and because it's completely inert and non-conductive, it doesn't do anything. I don't know what it's made of. It feels like it's got silicone in it. It makes your fingers very slippery. So it's very silicaceous. But yeah, It's similar to the stuff, if you ever pulled apart old CD-ROM drives and things, you'll find a lot of the big chips in the CD-ROM drive will have a square of this stuff on top of it, like so, and it'll be pressed against the backing panel of the drive just to transfer heat, cool things down. And you can do that. If you want to put a metal casing over this board and keep these chips cool, you just have little indentations in the case that softly bear upon this chip with this material through it. Of course, it takes a bit of calculation with your metal stamping die, but yeah, it's interesting stuff. I think I do have some in a bag somewhere, so I'm not going to bother keeping this, but I want to get this backing panel off safely. And I've also got the stand out so I can mount the panel directly to the stand. That's what these holes here line up with. The rest of the unit just hangs off the panel itself. It's all self-supporting. Support the panel and you avoid panel breakage. If you only mount off something on the base, you risk panel breakage through flexing and other movement, like that Panasonic that I dismantled. That only had mounts at the very bottom of the panel. There was nothing up the top. All that stuff was either missing or just not there to begin with. And as a result, flexing and other things had caused fracture in the corner of the panel. Both sides actually. There was one in the top corner and one in the bottom corner, because it wasn't properly supported. It may have fallen over. I'm guessing the TV fell over, but it's a fairly cheap method compared with having panel supports come all the way from top to bottom and support the entire back of the panel. LCDs are fairly flexible. I've seen LCDs go through hell and they keep working. It's only when you really strike the front of them very hard that they start to break, or you push on it very hard. Plasmas, they're just so much more fragile. You've got to be very careful with them. Remember what I was saying about goo under the boards? There it is. It's designed to transfer heat from this section of the board to the back of the panel as well. These whole things get very hot. They work at pretty high temperatures, but they are a fluorescent display panel, so they're not too bad. Don't really know where the term plasma comes from. When you really break it down how they work, they're just an array of CFLs, cold fluorescent lamps. Yeah, very complicated cold fluorescent lamp array, but it works. It's the what buffer is this one here? This is, I can't remember. I don't know. It's connected to the front glass anyway. The front layer of glass has electrical traces and things on it, and so does the back layer. And I believe the back layer is here because those control, well, these control vertical rows, these control horizontal rows, and yeah, they just send signals to each individual lamp to light up at a varied brightness level. Like full brightness will be at maximum voltage for that particular lamp, and say if it's a darker scene in a movie or something and there's a lot of red, like the image of blood in the dark or a very shadowy area, it'll bring the brightness down to a point where you can barely see the blood on the screen. You get what I'm saying. They're quite fascinating, they really are. I still don't fully understand how they work, but they really are fascinating. LCDs are so simple by comparison. These are just over-engineered, and they're a masterpiece of engineering let down by shoddy componentry most times. If these were built out of heavy-duty componentry, they'd last a long time. It's just the way things are going now though, it's just crap componentry. So yeah, I'll strip the rest of these boards off. I'll take the X and Y sustain, I'll take the main panel drive board, I'll take these buffer boards, that one there, what does that say? E buffer, logic E buffer. Take them. Yeah, YB upper buffer, YB lower buffer, and that'd probably be X sustain, front glass. Those aren't actually traces in there, it's just one solid connector. 1, 2 and 3, and they're all connected through to a common row. There's three, I think there's 3 grids that they're connected to through these connectors. So, quite interesting. Ah, there we go. Nice bare plasma monitor. In future, I'd love for TVs to be about, yeah, that thick, and you just stick them to the wall and that's the way it is. But trouble is, I've seen a lot of super slim TVs and things, but they're trying to cram large high-powered power supplies and stuff in the back of them, and how does the heat get out? Aside from absorbing into the back of the panel. That's the only issue with these things is you start cramming into such a tiny place, how does all the heat get out? I realise technology is pretty good, it doesn't produce as much heat as they used to. Like this old unit would have used about 600 or 700 watts of power. New ones by today's standards, even bigger ones, use 3/4 of that at the most. I think the 50-inch Samsung that I've got over there in the back, that uses less power than one of these old 42-inch standard definition ones. Only reason that's still in here is because it still smells a little bit like cigarette smoke. I don't think I'll ever get rid of it, so I'm just going to have to put it in my bedroom and just hang an air freshener on it. It's like a second-hand car that's got old man smell in it. You just keep an air freshener hanging off the rear view mirror for the rest of its life. You never get rid of it. But yeah, we'll do something fun with this another time. I'm going to put it outside for now. The whole idea is to clean up in here.